Hello there guys, welcome to my channel. Okay, in this video I'm going to present about a physics paper 2, October-November 2021, and the paper code is 22. Okay, so the time duration here is 45 minutes. So let us move to the first question. Okay, now number 1, a student is taking some measurements. Which measurement is taken directly using a micrometer screw gauge? Okay, micrometer screw gauge is to measure length. So length will be in a millimeter. So if you look at here, this is square, and here's volume, area, volume, here's length, and here is measurements for the area. So your best answer here will be C, because it's only for length. Now let us look at question number 2. Okay, question number 2, they will be asking which graph represents an object that is moving at a constant speed. Okay, now you see here, this is a distance and this is a time. So the distance and the time, you must have a line which is straight, either like this, or it can be either like this. Okay, the green color line or the blue color line. This is the object is at rest. And here, if you look at this, the gradient is at rest. Okay, this is at rest. And it is increasing in velocity. And the velocity increasing. Okay, it is not constant. The velocity is increasing, the speed. Okay, now same goes to with C. Here's at rest. At one point, the gradient is getting steeper, so the speed is increasing in a reverse direction. So this is, we can say, is a constant. Okay, so here we have a constant gradient, and is also, we can make it like a constant speed. So this is your answer D for number 2. Okay, now for number 3. Okay, in which situation does object X have a greater mass than object Y? Okay, for this kind of question, we have no choice but to go through the whole answer options. For A, object X is in a larger gravitational field than object Y, and both have a same weight. If they have a same weight, it doesn't mention that Y having a greater mass. Alright, so this is wrong. Now look at B. Object X shows a greater resistance to change in motion than object Y, and both experience the same resultant force. So if they're having a greater resistance, means they're having a higher inertia. Okay, this is having a higher inertia. So which means it shows X is, the mass of X is much more than the mass of Y. Okay, now let us go through the C. Object X has a lower density than object Y. They occupy the same volume. So if you look at the densities formula, here will be M over mass over volume. Also, if they're having a same volume, so which means that, let's say, here's X, here's X, here's for Y, this for Y. So we have a same volume. Okay, this is the same, and they mention object X has lower density, so the density is much more lower. So which means the mass of Y is greater than mass of X. So this is wrong. So now let us look at D. Object X moves at a greater speed than object Y, and both possess the same kinetic energy. So when you have this same kinetic energy, so they have, okay, for example, let us just elaborate this. we can cancel off this 1 over 2. Alright, this is for x and this is for y. So now we have this. Okay, now object x is moving at a greater speed. So let's say we just put here 2 and here we maintain as 1. So automatically what will happen here is this is for x and this is for the y. So here you will have mx over my, and here will be 1 over 4. So the ratio of the mass here, it shows that the mass of y is much more higher. So your best answer here will be by. Since D is wrong, A is also wrong. Okay, so this is the explanation for question number 3. Now let us move on with question number 4. Question number 4, which substance in the table has the lowest density? Density we can calculate by mass over volume. So when we calculate this, so here will be 1.2 over 1. This will be 1.5 over 1. So this is 1.2, this is 1.5, and here will be 1.8 over 2. So this is 0.9, and here you have 2 over 2, which is 1. So the lowest density here will be C. Okay, now we move on with question number 5 here. Okay, 3 simple machines are shown. We say we have 1, 2, and 3. Which machine are an application of the moment of force? So moment of force, please remember the formula. We have force times with distance, and this must be in a perpendicular. Let's say this is the distance, and here we have the force. Okay, so it must be in a perpendicular direction. Okay, so let me draw the line for you, the distance and the force. So here we have a distance. So here we will have a distance, and this is the force. This is distance, and this is the force. Okay, so 1 is selected. Now we go for number 2. Number 2, if you look at it, so the scissors, the force will be in this direction, right? In this direction, and this is the distance. So here we have the force and we have the distance, which is in a perpendicular direction. Okay, now if you look at here, this is the distance. Okay, normally when we want to turn the screwdriver, we have to move to this way or this way, right? So in both way, it is having a perpendicular direction. So the answer we have to select is 1, 2, and 3. Okay, now we go to number 6. Okay, a spring which obeys Hooke's law has an unstretched length of 10 centimeters. So this is the original length. A load of 20 Newton is suspended from the spring. A new length of the spring is 36. So which means that, okay, so this is about 20 Newton and the new length here will be 36. So your extension here, we have to minus with the original length, which comes is 26 centimeter. So extension, x is the extension, 26 centimeter. So by using a Hooke's law, F equals to spring constant times with the extension of the spring. So here we have about 20 Newton and here we have about 26 centimeter. So we have to change this one to meter, but if you look at the answers, everything is in centimeter. So we just have to use this. So when we divide, we will be getting here 20 divided by 26. You got here about 0.77 Newton per centimeter. Okay, so your best answer here will be boy. Okay, this is the calculation for this. Now let us look at question number 7. Okay, question number 7. A rocket is launched upward from the surface of the moon. Hot gas are ejected downward over a very short period of time. Which statement is not correct? Rocket experience a downward force. Yes, obviously. So let's say we have a rocket here. I just draw a triangle. So obviously here you have a downward force, which is the weight. Rocket experience a upward force. Yes, when you have the gas pushing in. Okay, so you will have the upward lifting force. Yes, is correct. Now here the total momentum of the hot gas is equal to the momentum of the rocket. Okay, if you look at C and D, the answer is very close. The total momentum of the hot gas and rocket when the hot gas have been ejected is 0. So this is a type of explosion. So explosion type of momentum, we have to use this formula. M1 V1, M2 and V2. So if you notice here, let's say this is for the gas and this is for the rocket. So let's say we move the entire thing to here. It becomes minus M1 V1 equals to M2 and V2. So even though the C is correct, the total momentum of the hot gas is equal to the momentum of the rocket, but the direction must be opposite. Okay, so they are asking for the not correct. So your answer is C. D is correct because it's equals to 0. C is partially correct. If they add on with the opposite direction, then it is correct. Okay, so this is for number 7. Now for number 8, electrical energy may be obtained from a nuclear fission. In which order is the energy transferred in this process? Okay, now we have fuel, generator, reactor and boiler, and turbine. So normally the arrangement here will be turbine will come first. Okay, turbine is like a big dynamo. When the fan is being turned. Okay, when the fan is being turned, so I just draw it in this way, the turbine. Okay, when it is turning, normally it will be attached to a generator. Okay, this generator is the one will be converting the kinetic energy into the electrical power source. So should be turbine to generator. And then the nuclear fuel is the radiation, where you have the fission process. Big molecule will be bombarded with a neutron to produce smaller molecules, and this process you will have tremendous amount of energy. So this energy it will be inside the reactor and also the boiler. So we need this one first. So it should be 1, 2, 3 and 4. Your answer is D over here. Okay, this is for number 8. Okay, let us look at number 9. Okay, number 9. A box of mass M slides down a slope of length L against a friction force F. It descends a vertical height of D. Okay, as the box slides down the slope, it loses gravitational potential energy and it does work against the friction. Okay, now which row gives a loss in gravitational potential energy and work done against the friction. Okay, now the formula for gravitational potential energy is m, g and h. So if you look closely, the height here is replaced with the density, so should be m, g and d. This is the gravitational potential energy. But for work done is against the friction, so it should be force times with the distance. Okay, force times with the distance. So here, so the distance here is replaced with the L, so should be F times with L. So should be, this is not wrong, this is wrong. Should be A as your answer, correct answer. Okay, this one and this one. Okay, now we go for number 10. Okay, number 10, a rope connected to a pulley system and motor is used to lift a different object through different distance. The time taken to lift each object is the same. The diagram is not to scale. Okay, which motor requires the greatest power? So now let us look at the question here, which requires the greatest power. So we have A, B, C, D, and here we have the motor, the pulley, the platform, and also the weight here. So now the power is actually equals to energy over time. So since the time is all the same, we just have to calculate the energy here. The energy here, the relevant energy here is a gravitational potential energy, where we have to calculate the energy here alone. So mgh, so we have to calculate for all of this question to have the comparison. So now this is 10 kg times 10 times with 2 for the height. You'll get here about 200 joule, and here will be 10 times 10 times 1, which is about 100 joule, and here's about 5 times 10 times 3, so which is about 150 joule, and here will be 2 times 10 times with 3, so which will give us about 60 joule. So the greatest power here, the time is constant, because we can just put here 1 because it's the same time for all. So it's all depending on the energy. So the highest energy here is A. Okay, so this is for number 10. Okay, now let us move on with the question number 11. So which equation can be used to calculate the pressure at the depth h beneath the surface of the liquid? So this is the basic physics formula for the pressure, h rho g. Okay, h rho g. So your answer is C here. Okay, a liquid is evaporating. The liquid is not boiling. Which statement about the liquid is correct at an instant in time? So we can see here, and any molecule can escape and from any part of the liquid. Any part of the liquid. So you have to remember the evaporation. Let's say this is the drop of the liquid. Okay, drop of the liquid in on a surface. So the first layer molecules. So let's say I just put here, this is the first layer. This is the molecules. Only these molecules can evaporate. Okay, they can change the state, and not the molecules inside. So they have to wait until this layer went off, then it comes to the second layer. So this is the evaporation. So this is wrong here. any molecule can escape and from any part of the liquid. It should be only molecules with enough energy can escape, but from any part of the liquid. So this is also wrong. So your best answer here will be C. They can escape when they have enough energy, and only from a liquid surface. Okay, so 12 is C here. Okay, number 13, a gas is contained in a sealed container in a laboratory. The temperature of the gas increases. What happened to the average speed, and what happened to the total kinetic energy of the gas molecules? So they are in a sealed container. They are sealed in a fixed shape container, and the temperature of the gas is increasing. So what will happen to the average speed and the total kinetic of energy? The speed obviously will increase with the increased collision. Okay, at the same time, so when the speed increases, the total kinetic energy is also depending on the speed. So both will have an increase. So this is your answer. Okay, now let us look at question number 14 here. An aluminium block has a mass of 200 gram. Specific capacity of the aluminium is 900. How much energy is needed to increase the temperature of the block from 20 to 110? So we have to use mc theta. So this is about 0.2. This C is 900, and the temperature change here is about 90. So which will give you about about 16,200 and a joule. Okay, which is C as your answer. Okay, now let us go to number 15. The diagram shows the apparatus used to measure the specific latent heat of vaporization of water. Okay, after the water begins to boil, 110 gram of water is converted to steam in 120 seconds. What's the value of the specific latent heat of vaporization of water? So we have to use this formula ml. So this is the energy. Okay, this is the energy. So 2 kilowatt, 2000 watt, and the time here is about 120. The mass here is about 0.11, and the specific latent heat. So we have to divide this. So which 2000 multiplied 120 divided by 0.11. This is your latent heat. So here the answer here will be So this is the answer that I have obtained, and the nearest answer what we are getting here is 2.2 million joule per kilo. Okay, your answer is D here. Okay, now for number 16, the diagram shows a pan used for cooking food. This is the handle of the pan, and this is the base of the pan. So now the base of the pan needs to be a good thermal conductor, but the handle of the pan where we are putting our hand must be a poor thermal conductor. So your answer is B over here. For number 17, the diagram shows the pattern of the water wave as they pass through a narrow gap. So this is the narrow gap here. Which row names the process shown and describe the effect of using a wider gap? So if you're using a wider gap, okay, so what happens? You won't have the diffraction process, and the wave let's say, let me draw here, this is the wave, and it will come out as the normal wave. Okay, so it will spread lesser. So it's diffraction and it spreads out lesser. C is your answer. Which row is not correct for a wave on the surface of water? Amplitude is meter, frequency is hertz, wavelength is lambda, speed is meter per second. Not correct for a wave on the surface of water. Okay, this is a usual unit. Wavelength is the length of the wave. So the length of the wave should be measured in meter. The lambda is a symbol of wavelength. So C is your answer here. Okay, number 19. The diagram shows how a ray of light refracted from going from air to perspex. Okay, this is the air to perspex. So the critical angle of perspex is C. Which expression is correct? So for the refractive index, we will have N. Refractive index equals to 1 over sine C. And the normal refraction angle is sine I sine R. So the sine I here will be the incident wave or the air. We will give more importance to the air. So following this, okay, so we will have sine. So this is the X over Z. Okay, so when we make it equals, this one equals to this one is a sine X over sine Z equals to 1 over sine C. So if you notice the answer here, everything we will have is a sine C. So we just have to inverse this, okay, upside down. So you have sine Z over sine X equals to sine C. So this is your answer. So your best answer here will be boy. Okay, number 20. The diagram shows a ray of light in air incident on a glass block. Some of the light refracted and some of the light is reflected. Okay, two angles P and Q are marked on the diagram. So which row gives the angle of incident and states whether total internal reflection occurs? Okay, angle of incident is surely a Q here. Okay, Q. And you have to understand total internal reflection here occurs when the light is going from medium, okay, denser medium to less denser. So if you notice here, this is air to glass, less denser to denser. Okay, so which means total internal reflection here will never occur. So your answer here will be C, Q and no. Okay, so this is your answer for question number 20. Okay, for number 21, the letter F is reflected in a mirror. So the image here should be, this one will be coming first. Okay, so that is, so this is the image that we will be getting here. So your answer here is B. Let us look at number 22. Okay, number 22, the sun emits infrared radiation and also light. Light from sun reaches the earth in 8 minutes. Which row gives correct information about the infrared radiation? So if you look at our EM, our electromagnet, so first we will have a radio, okay, a radio wave, then we will have a microwave, then we will have an infrared, okay, so this one I just make it in full, infrared, then we will have a visible light, okay, visible, I just make it light here, then we will have UV, X-ray, and also gamma ray. Okay, so now here you have an increasing in a frequency and decreasing in a wavelength. So here we will have the longest lambda, the wavelength, and here we will have the shortest wavelength here. So if you notice that light, they have a longer lambda. Okay, longer lambda. Okay, so your answer here should be longer than a wavelength of light. Okay, so it should be A and B, A or B. If you look at the time taken, the speed of all the EM is the same. Okay, which is 3 multiplied with 10 to the power of 8 meter per second. So it should be 8 minutes at the same time. So your answer here will be A. Okay, now we move to 23. So which statement about lateral magnetic wave is not correct? So they travel at 3 multiplied with 10 to the power of 8 meter per second in vacuum. This is correct. They transfer energy. So wave, they have to transfer the energy. That is their main objective of the wave, like sound wave. Okay, so they travel at this is actually the speed of sound. The speed of sound in air, approximately 330 meter to 340 meter per second. Okay, so your answer here is C. And D is correct. They are all is a transverse wave. Okay, what is ultrasound? Our hearing frequency, human hearing frequency is 20 Hz to 20,000 Hz. So if it's ultrasound, is beyond than a human's hearing range. So this is under frequency. Okay, frequency. So should be higher pitch or lower pitch. Ultrasound should be a higher pitch. Loud we cannot, because this is an amplitude. To quiet and loud is more to amplitude. So we have to look at the frequency. Is a higher pitch or lower pitch? So if a beyond 20,000, it should be higher pitch. Okay, so your answer is boy over here. Okay, number 25. Which diagram shows the electric field pattern between two oppositely charged parallel metal plates? So if you're asking for two oppositely charged positive plate and also negative plate, so remember the charge will be going out from positive toward the negative. The arrow should be like this. If it's a circle, it should be going all the way around with the arrow going out of the sphere. Okay, so this is the pattern. If it's negative, it's coming back, coming toward the sphere. Toward the sphere. So your answer here is A. Okay, 26. Which circuit symbol represents a component used to measure electric current? This is ammeter. Okay, this is an ammeter. So should be A. Ammeter. So 27, the graph shows current voltage characteristics of a conductor. Where on the graph can Ohm's law be applied to the conductor? Ohm's law must be a straight line. Okay, must be a straight line. V, I, or I, V. It doesn't matter, but have to be a straight line. So should be from here to here. It's a straight line between P to Q. Okay, that's your answer here. Okay, now we move on with question number 28. It looks complicated, so let us do this. 28. The diagram shows a circuit containing two resistors. This is 1 and 2 ohm. A voltmeter is connected across 1 ohm. Voltmeter is at 1 ohm. Okay, by connecting P to X. P2X over here, okay, and then the reading of the voltmeter is 6. So when they are connected here, this is 6 voltage. This move to point Y, is then move to point here. Okay, now first let us calculate the current produced over here, okay, because the current here will be the same. So V equals to IR, V is 6 over the resistance, okay, 1. So the current here is about 6 ampere. So the 6 ampere current is also moving across the 2 ohm resistance. So we apply the same formula again, 6 and the resistance is 2, which will give you about 12 watt. So your answer here is C. C for, oh, sorry, this is a small error. This 12 is across the 2 ohm. So when they're asking the total P to Y, so which means the entire thing. So from here to here, so here is about 6 voltage and here is about 12 voltage. So the total here is about 18 voltage. Okay, the answer is D here. It's not C, D. There is a current I in a resistor. The potential difference across the resistor is V. Okay, which other physical quantity is needed to be able to determine the energy transferred by the resistor? So we have here the current I and also the V. So to measure the energy, when you're asking the energy, we need to have V, I and T. So we are missing this T. The time T for which there is a current in the resistance. Okay, so we need the time. Okay, number 30, the diagram shows pair of circuit containing logic gates. In which diagram does the lower circuit of the pair behave differently from the upper circuit? Behave differently, it means they are giving an opposite output. So should be here, this is not gate, this is 0, 1 or 1, 0. This is AND gate, so should be 0. So this is the AND gate's truth table. Okay, truth table A, B, this is the input, 0, 0, 0, 1, 1, 0, 1, 1. So your output here will be 0, 0, 0, 1. This is for AND gate. And for NOT gate, okay, this is AND gate. If you have a NAND gate is this one. You have a dot, you have a circle here. Okay, so it should be the opposite. 1, 1, 1, 0. Okay, now we move on with this. Okay, now we look at is there any OR? Okay, OR gate. For OR gate, truth table is A, B, X. 0, 0, 0, 1, 1, 0, 1, 1. So here you'll be getting 0, 1, 1, 1. For NOR gate is the thing that with the circle in front of the OR gate. So here you have 1, 0, 0, 0. Okay, so this is the truth table for the OR gate and also the NOR gate. So now when you have 0, so it means 0 at both sides. Okay, this is NAND gate. Okay, this is NAND gate. So we have to look at here. So it will behave 1, and if it is 1 here, okay, if it's 1, it will give you 0. So it behaves the same. And let us look at B. So here you will have NAND gate 2 times. So let's say we put here 0, you will have 1. If it's 1, you will have 0. So for NAND gate, let's say we just change to 1 0. Here we should get here 0. So if 1 0, we just look from here, you have to get 1, which means if 1 is 0. Okay, now we look at, so this is correct, it's the same. So now here, this is OR gate. OR gate, we have to look at this. If it's 0, 1, then you will have 1 here. So if it's 0, 1, OR gate, NOR gate, you'll be getting, you just have to look at here. Here you'll be getting 0. If it's 0, look at here, this part. This one, you'll be getting here 1. So which means this is also the same. NAND gate. So if it's 0, 1, you should be able to get here 0. So now we try with the circuit below here. 0, 1, we look back at here at this. So NOR gate, you are getting here 0, and here be getting 1, which is different, right? So your answer here is D. Okay, for number 31, several cells are connected in series as shown. What is the combined electromotive force EMF of the cells? So it will be sum of the EMF. So that is your best answer here, sum of the EMF. Example, now you have a 1.5, 1.5, 1.5 and 1.5 voltage. So you just have to times with 4 here, and total of this voltage is 6 watt. Okay, so this is the answer for number 31. Now let us continue with 32. Okay, 32. Two resistors with the resistance R1 and R2 are connected in parallel. The resistance R1 is greater than the resistance of R2. What is the resistance of the parallel combined? So it should be, okay, example, if let's say we have a doubt on this, we just have to make it like 6 ohm, and here's about 3 ohm. Then we do the calculation. Okay, so example, like 1 over 6, 1 over 3, 1 over R total. So here becomes 6, here's 2, 3 over 6, then we change back. Okay, just invert this, you got 6 over 3, which will give you about 2 ohm. So if you look at it, it is lesser than both of these, right? So it's less than R1 and R2. Okay, now we move forward with number 33. The diagram shows a motor connected to an AC supply. The circuit is incomplete. Which device needs to be connected between the X and Y to prevent the wires from overheating, and if a fault in motor causes the current to get too high? So we have to put here a fuse. Fuse is a most cheapest protection method. Okay, fuse. So this is the fuse. Inside here you have a wire. If it's overheat, this wire will get disconnected, and you won't have the current flowing. Okay, so this is for number 33. Okay, number 34. The diagram shows a wire between the two magnets. An electromotive force EMF is induced in the wire when it is moved up between the two magnets. Okay, 4 tests are done. Okay, this is induced current. Okay, you have direction of the movement reversed, direction of the magnetic field reversed, wire is moved more quickly, you have a higher, so this is same magnitude, and this one is higher magnitude. okay, higher magnitude, the magnetic field strength is decreased. So which is the strength of the magnet is reduced. So this is you can say reduce, or you can say lower magnitude. Okay, all this stands for magnitude. So which test will induce a smaller EMF, smaller magnitude in the wire? So you can say your answer only 4D. Okay, number 35. For portion of the current carrying coil in a magnetic field as in a DC motor as shown. Diagram 2 and 4. 2 and 4, the coil is at 45 degrees to the field line. Okay, so which row is correct? Turning effect of the force in the portion of 1 and 3, it will be different, and turning effect of the force in position 2 and 4. So 1 and 3, okay, 1 and 3, so here you will have the maximum. Okay, this one is almost no turning force. Okay, there is no effect. It will turn around by inertia. Okay, so this one must be different. And the 2 and 4, since the angle is the same, right? So they should have the same turning force. So the answer is boy over here. Okay, 36. The diagram shows the magnetic field due to a current in a solenoid. The direction of the current is reversed. So the magnitude here will remain unchanged, and the direction of the magnetic field here will also change. Okay, direction will be changed. So your answer here will be C, because they just changed the direction of the current, positive to negative, and then they change it to negative and positive here. Okay, number 37. Okay, the nucleus of a americium atom contains 146 neutron, and this is 95 proton. It decays by emitting an alpha particle. How many neutrons and how many protons remain in the nucleus when this form of americium decays? Decay by emitting alpha particles. So we can place here, example, this is the americ. Okay, let's just make it A here. So here's 95, and above here should be a nucleon number. So 146 plus with 95, so here you should get 241. The proton number, sorry, the neutron number here is 146. So here, when it decay, it will decay a particle 42 alpha. Okay, 42 alpha. So which is helium. So this is alpha. So the number here will be 93, and here we have to reduce to 4. So 214 minus with so you should be able to get here 27237. Okay, so this is what's supposed to get here. So proton is 93, and then your neutron, your new neutron here will be 144. So this is your answer. So your answer is C. Okay, so this is your explanation for this. Okay, question number 38. A sample of americium decayed and changed into newtonium. Half-life of americium is 432 years. Which fraction of the americium will remain after 1728 years? So we just have to divide this. So it's a how many half-life is that? So this is about 4 half-life. Okay, so it's about 4 half-life, which means fraction. So you can say it's 100%. Then you divide it by 2. Maybe I can use a fraction method over here. Divided by 2, then divided by 2 again, then divided by the 2 again. So you have about 1/4, so which is about 50%, and it reduced to 28%, then it reduced to 12.5%. So 12.5% over 100, you'll be getting 1/8. Okay, so C is your answer. And C is not your answer, so this is wrong. So you know why? Because when you calculate this, you will be getting into a point form. You'll be getting into a, okay, this is 4 times. So this is 1, 2, 3, and you need another one more here, which is 4, 1/16. So it should be divided into half, 6.25. So this is not your answer. Your answer is supposed to be this. Okay, I'm very sorry, I never noticed this. Should be 4. Okay, should be 4. So your answer you should have here about 4 half-life. 1 half-life, second half-life, third half-life, and the fourth half-life. Okay, so 1/16. Okay, number 39, the graph shows a decay curve of 4 different radioactive isotopes. Which isotopes have a larger half-life? So if you look at here, this is the original. Okay, this is the original. So when they reduce to half, let's say this is the half of the original. This is NO, this is, let me erase this. Okay, this is NO/2. So it's very short. This is very short. Okay, this is very short half-life. So if you look at, they're asking for the largest half-life here should be A, because it takes a long time for it to reach to the half. Okay, now we go to number 40. So the diagram shows alpha particle and beta particle passing through electric field. So okay, just remember this. Alpha is a positively charged. Okay, alpha is a 4,2 helium, so positively charged. It will be attracted to the negative plate. Negative. Beta is a electron, so it's a negative charge. It will be attracted to the positive charge. So this is wrong, and you can see this part. Beta, this is also wrong. Alpha here is also wrong. Okay, your answer should be, most possible answer is boy, because A, even though the direction is correct, but it's still wrong, because the beta in his electron is very light. Okay, light in mass, little mass, but this is much more heavier. So supposedly let me show you here, like this is a positive charge and this is a negative charge. Okay, let me draw an alpha. So the green color is alpha, so it will be like this. Okay, but if you look at the beta, this is beta, it is very quick. So there is a difference in the angle here. This is a smaller angle and this is much more bigger angle. Okay, so your answer here will be boy. It is slightly attracted to the negative. So I hope you learned something in this video. Thank you for watching, and please like and please subscribe. Thank you.